Reverse polarity in house wiring can stem from several potential causes. Firstly, incorrect fixture connections play a significant role. When the black, or hot, wire from a switch is incorrectly connected to the white, or neutral, wire in fixtures, it can reverse the polarity. Secondly, mixed up neutral and hot wires can be a factor. During renovations or alterations, neutral and hot wires can be inadvertently swapped, leading to reverse polarity. Thirdly, electrical panel errors are a potential source of the problem. Mislabeled or improperly connected wires within the electrical panel can create a reverse polarity situation. Loose connections at the panel can also cause intermittent polarity issues. Fourthly, faulty switches or outlets can contribute to reverse polarity. Worn or damaged switches or outlets can malfunction and cause polarity problems. Fifthly, aluminum wiring, commonly found in older homes, can experience corrosion and oxidation. This leads to increased resistance and potential reverse polarity. Sixthly, improper grounding can create issues. Insufficient or incorrect grounding can create a path for electricity to flow backwards, resulting in reverse polarity. To determine if reverse polarity exists, one can use a non-contact voltage tester. When you touch the hot wire, the tester should light up red. When touching the neutral wire, the tester should light up green. If the tester lights up red for neutral and green for hot, the polarity is reversed. Correcting reverse polarity involves several steps. Firstly, turn off the power to the circuit at the electrical panel. Secondly, identify the reverse wires and correct the connections. Thirdly, if necessary, replace faulty switches or outlets. Fourthly, ensure proper grounding connections. Fifthly, inspect the wiring thoroughly for any other potential issues. Sixthly, turn the power back on and verify the polarity is correct. It is highly recommended to seek the assistance of a qualified electrician to diagnose and correct reverse polarity safely and professionally. Electricity flows through wires much like water flows through pipes, but instead of water pressure, we have voltage, measured in volts. Think of voltage as the electrical potential difference that pushes the current measured in amps through the wires. This current is what powers our lights, appliances, and devices. In a properly wired circuit, the hot wire, typically black, carries the voltage from the electrical panel to the device. The neutral wire, typically white, provides a return path for the current back to the panel. The ground wire, typically green or bare copper, is the safety wire that provides a path for fault current to flow back to the panel, tripping the circuit breaker and preventing electrical shock. Reverse polarity occurs when the hot and neutral wires are swapped, either at the outlet, the fixture, or in the electrical panel itself. This means that the device is still receiving voltage, but the return path is not what it's designed to be. This can create a dangerous situation, as the device's internal components may not be properly insulated from the energized hot wire. The consequences of reverse polarity can range from minor inconveniences to serious safety hazards. One potential problem is that appliances may not operate correctly. For example, a lamp might stay dimly lit even when switched off, or an electronic device might malfunction. More seriously, reverse polarity can increase the risk of electrical shock. If a device is not properly grounded and the hot and neutral wires are reversed, touching the device's metal casing could result in a shock. In some cases, reverse polarity can also damage appliances or even cause a fire. Because of these risks, it's crucial to identify and correct reverse polarity as soon as possible. Several factors can contribute to reverse polarity in a home's electrical system. Incorrect wiring is one of the most common causes. This can happen during initial construction, renovations, or repairs if the electrician or homeowner is not careful to connect the wires correctly. Over time, wiring can also become loose or corroded, leading to reverse polarity. In older homes with aluminum wiring, this is a particular concern, as aluminum is more prone to corrosion than copper. Another potential cause is faulty electrical components. Outlets, switches, and light fixtures can all fail over time, and in some cases, this can lead to reverse polarity. For example, an outlet might have internal damage that causes the hot and neutral wires to cross. Finally, problems in the electrical panel itself can also cause reverse polarity. If the breakers are not properly installed or if the wiring is not correctly connected, it can create a situation where the hot and neutral wires are reversed for an entire circuit. To determine whether a home has reverse polarity, there are several testing methods available. A simple way is to use an outlet tester, which plugs into an outlet and uses lights to indicate whether the wiring is correct. If the tester indicates reverse polarity, it's important to investigate further to determine the cause and extent of the problem. A more comprehensive test involves using a multimeter to measure the voltage between the hot, neutral, and ground wires. In a properly wired circuit, the voltage between the hot and neutral wires should be approximately 120 volts. The voltage between the hot and ground wires should also be approximately 120 volts, and the voltage between the neutral and ground wires should be very low, ideally close to 0 volts. If the voltage readings are significantly different from these values, it could indicate reverse polarity or other wiring problems. Once reverse polarity has been identified, it's important to take steps to correct the problem. The first step is to turn off the power to the affected circuit at the electrical panel. This is crucial for safety, as working on live wires can be extremely dangerous. Next, carefully inspect the wiring at the outlet fixture or electrical panel where the reverse polarity is suspected. Look for any obvious signs of incorrect wiring, such as wires that are connected to the wrong terminals or wires that are loose or damaged. If the problem is found at an outlet or fixture, simply disconnect the wires and reconnect them in the correct order, making sure that the black wire is connected to the hot terminal and the white wire is connected to the neutral terminal. If the problem is in the electrical panel, it's important to proceed with caution. Working in the electrical panel can be dangerous, and it's generally best to call a qualified electrician to handle the repairs. However, if you're comfortable working in the panel, carefully disconnect the wires and reconnect them in the correct order, following the panel's wiring diagram. After correcting the wiring, it's important to test the circuit again to make sure that the reverse polarity has been resolved. Use an outlet tester or a multimeter to verify that the voltage readings are correct and that the wiring is now properly polarized. In some cases, reverse polarity may be caused by a faulty electrical component, such as an outlet or a switch. If this is the case, simply replace the faulty component with a new one, making sure to connect the wires correctly. In older homes with aluminum wiring, reverse polarity can be a recurring problem due to corrosion. To address this, it may be necessary to replace the aluminum wiring with copper wiring, which is more resistant to corrosion. It's also important to ensure that the wiring is properly grounded. A properly grounded electrical system provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker and preventing electrical shock. If the grounding is inadequate, it can increase the risk of electrical shock in the event of reverse polarity or other wiring problems. In conclusion, reverse polarity is a potentially dangerous wiring problem that can have a variety of causes. By understanding the causes of reverse polarity, testing for it, and taking steps to correct it, homeowners can help ensure the safety of their homes and families. However, it's important to remember that electrical work can be dangerous, and it's always best to consult a qualified electrician if you're not comfortable working with electricity. Electrical systems in residential buildings operate on alternating current, or AC, which means the flow of electricity periodically reverses direction. In the United States, the standard voltage for residential circuits is approximately 120 volts. This voltage is delivered through three wires: the hot wire, the neutral wire, and the ground wire. The hot wire carries the electrical current from the power source to the electrical device, while the neutral wire provides a return path for the current back to the source. The ground wire provides a safety path for electrical current in case of a fault, such as a short circuit. When an electrical outlet is wired correctly, the hot wire is connected to the smaller slot, the neutral wire is connected to the larger slot, and the ground wire is connected to the round hole. This configuration ensures that electrical devices receive the correct polarity, which is essential for their proper operation and safety. Reverse polarity occurs when the hot and neutral wires are switched, meaning the hot wire is connected to the larger slot and the neutral wire is connected to the smaller slot. This can happen due to various reasons, such as incorrect wiring during installation or repair, damaged wiring, or faulty electrical components. While reverse polarity may not always cause immediate problems, it can create a potential safety hazard. In some cases, it can cause electrical devices to malfunction, overheat, or even become damaged. It can also increase the risk of electrical shock, especially if the device is not properly grounded. Identifying reverse polarity typically involves using a simple electrical tester, such as an outlet tester or a multimeter. An outlet tester is a small device that plugs into an electrical outlet and uses lights to indicate whether the wiring is correct. If the tester indicates reverse polarity, it means the hot and neutral wires are switched. A multimeter is a more versatile tool that can measure various electrical parameters, including voltage, current, and resistance. To test for reverse polarity with a multimeter, you would measure the voltage between the hot and neutral slots, as well as the voltage between the hot and ground slots. If the voltage readings are not what they should be, it could indicate reverse polarity or other wiring problems. Correcting reverse polarity requires identifying the source of the problem and then rewiring the electrical outlet or device accordingly. This typically involves turning off the power to the circuit at the circuit breaker panel, removing the electrical outlet or device, and then reconnecting the wires in the correct order. It's important to note that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you're not comfortable working with electricity. In addition to reverse polarity, there are other common wiring problems that can occur in homes. These include open circuits, short circuits, and ground faults. An open circuit occurs when there is a break in the electrical circuit, preventing the flow of electricity. This can be caused by a loose wire, a broken wire, or a faulty electrical component. A short circuit occurs when there is an unintended connection between the hot and neutral wires, causing a large amount of current to flow through the circuit. This can be caused by damaged wiring, faulty electrical components, or moisture. A ground fault occurs when there is an unintended connection between the hot wire and the ground wire, causing electrical current to flow through the ground path. This can be caused by damaged wiring, faulty electrical components, or moisture. All of these wiring problems can pose a safety hazard, and it's important to address them promptly. If you suspect that you have a wiring problem in your home, it's best to consult with a qualified electrician who can diagnose the problem and make the necessary repairs. Regular electrical inspections are also a good way to identify potential wiring problems before they become a safety hazard. Electrical systems are designed with safety in mind, incorporating features like circuit breakers, ground fault circuit interrupters, and surge protectors to protect against electrical hazards. Circuit breakers are designed to trip or turn off when the electrical current exceeds a safe level, preventing overloads and short circuits. Ground fault circuit interrupters, or GFCIs, are designed to detect ground faults and quickly shut off the power to prevent electrical shock. Surge protectors are designed to protect electronic devices from voltage spikes, which can damage or destroy sensitive components. By understanding the basics of electrical wiring and safety, homeowners can help ensure that their homes are safe and free from electrical hazards. However, it's important to remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you're not comfortable working with electricity. The National Electrical Code, or NEC, provides comprehensive standards for electrical wiring and safety. This code is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Local jurisdictions may adopt the NEC or modify it to meet their specific needs. Electrical contractors and electricians are required to follow the NEC when installing or repairing electrical systems. This helps ensure that electrical work is performed safely and correctly. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. By following the NEC, electrical contractors and electricians can help protect people and property from electrical hazards. In addition to the NEC, there are other organizations that provide standards and certifications for electrical products and equipment. These organizations include Underwriters Laboratories, or and the Canadian Standards Association, or CSA. UL and CSA test electrical products and equipment to ensure that they meet safety standards. Products that have been tested and certified by UL or CSA are marked with a listing mark, which indicates that they have been found to be safe for their intended use. When purchasing electrical products and equipment, it's important to look for the UL or CSA listing mark. This helps ensure that you are buying safe and reliable products. Electrical safety is everyone's responsibility. By following safe electrical practices, homeowners can help prevent electrical accidents and injuries. These practices include never overloading electrical circuits, keeping electrical cords and appliances away from water, and replacing damaged electrical cords and plugs. It's also important to have a qualified electrician inspect your electrical system regularly to identify and correct any potential problems. By working together, we can make our homes and community safer from electrical hazards. The principles of electricity are used in various applications. Firstly, they are used in power generation. Power plants use generators to convert mechanical energy into electrical energy. This electrical energy is then transmitted through power lines to homes and businesses. Secondly, they are used in electronics. Electronic devices such as computers, smartphones, and televisions use electrical circuits to process and display information. Thirdly, they are used in transportation. Electric vehicles use batteries to store electrical energy, which is then used to power an electric motor. This electric motor drives the wheels of the vehicle. Fourthly, they are used in medicine. Medical devices, such as pacemakers, defibrillators, and imaging equipment, use electrical signals to monitor and treat patients. Fifthly, they are used in industry. Industrial equipment, such as motors, pumps, and robots, use electrical power to perform various tasks. The future of electricity is expected to be shaped by several trends. Firstly, renewable energy is increasingly becoming a dominant source. Solar, wind, and other renewable energy sources are becoming more affordable and efficient, which is driving their adoption. Secondly, smart grids are being developed. Smart grids use sensors, communication networks, and data analytics to improve the efficiency and reliability of the electrical grid. Thirdly, energy storage technologies are being advanced. Batteries and other energy storage technologies are being developed to store electrical energy and make it available when needed. Fourthly, electrification is expanding. Electric vehicles, electric heat pumps, and other electrical technologies are becoming more common, which is increasing the demand for electricity. Fifthly, energy efficiency is being improved. Energy-efficient appliances, lighting, and building designs are being developed to reduce the amount of electricity needed to power our homes and businesses. These trends are expected to lead to a more sustainable, reliable, and affordable electrical system in the future. There are many resources available for learning more about electricity. These resources include textbooks, websites, online courses, and professional organizations. Textbooks provide a comprehensive overview of electrical theory and practice. Websites offer a wealth of information on various electrical topics, from basic concepts to advanced applications. Online courses provide a structured learning environment for those who want to learn more about electricity. Professional organizations, such as the Institute of Electrical and Electronics Engineers, or IE, offer opportunities for networking and professional development. By taking advantage of these resources, you can expand your knowledge of electricity and advance your career in the electrical field. The use of electricity has transformed the world in countless ways. From lighting our homes to powering our industries, electricity has become an indispensable part of modern life. As we continue to develop new electrical technologies, we can expect electricity to play an even greater role in our future.